This episode of Earl Grey is brought to you by Audible.com, offering more than 180,000 titles for smartphone, tablet, and desktop. To get a free audiobook of your choice and help Trek FM at the same time, visit audibletrial.com/trekfm. And also by Enterprise in Space, an international program of the nonprofit National Space Society. Find out how you can help science and education and become a virtual crew member aboard the NSS Enterprise Orbiter by visiting enterpriseinspace.org.
This is Dwight Schultz. I played Reginald Barclay, otherwise known as Broccoli, on Star Trek Next Generation and Voyager. You're listening to Trek FM.
Tea, Earl Grey, hot.
Welcome to another cup of Earl Grey, Trek FM's dedicated podcast to the next generation. I'm your host, Joe Keegan, and Amy, as usual, is away again. She's somewhere in the middle of the Caribbean on that Star Trek The Cruise 4, but we've not heard anything from her, so she's probably just enjoying herself way too much. Joined with me today is Justin Oser as normal. Reliable, trustworthy Justin. How are you today?
Doing well, yeah. Just jealous of Amy. I know we haven't seen things from her. I think on the cruise, maybe it costs extra to get internet access, but I've been seeing some stuff from other people. And
yeah, me too. And that's
amazing. Very jealous.
I had a theory that she's never been on a boat before, so because she lives in the middle of the desert, so got seasick and then had to leave. But that's just the way my brain goes.
That's quite a speculation.
Scenario,
I think she's probably having a good time.
Is it not like Occam's razor or something like that? The simplest explanation is probably true. I know I'm kind of
yeah, and the simplest explanation is she doesn't have internet access, but she is having a great time.
True, that's totally right. Yeah, it's just the way my brain works. Yeah. Anyway, we don't have any Babel conference feedback this week.
I think we'll catch up on it next week.
We'll bring some to you next week when Amy's hopefully going to be back, looking all sun-kissed and even more beautiful than normal. So, we have a special guest with us today in the form of Mike Wong. I've never met Mike before or podcasted with him or really seen his face until like 5 minutes ago. So, it's really good to have him on this episode of Earl Grey. Mike, interestingly, is a planetary scientist. And I Googled him. As you do, as it's possible to do in 2020. And I found his bio page on the University of Washington Department of Astronomy. And it just sounds like the coolest thing ever. I study planetary atmospheres, habitability, biosignatures, and the emergence of life. Welcome, Mike, to Earl Grey.
Thank you so much for having me. It's a real honor to be on the Trek FM network and to be on Earl Grey once again.
Yes, because the last time you were on Earl Grey was Earl Grey 237, talking about exotic solar systems.
And what are we up to now?
This is 316.
Oh,
so
my goodness.
It's been like, 80 episodes. But yeah, the last time you were on, I think it was it the one with Elise who used to be your co-host on Strange New Worlds, and we were talking about the chase.
That's right. Yeah, that was a fun conversation. I can't believe it's been 80 episodes. You all do so much great work. I mean, 80 episodes is just about how many episodes of Strange New Worlds there is in total.
Yeah.
So.
Okay. Well, we've had a little head start since Earl Grey's been going since 2013.
Yeah.
But it's really great to have you back, Mike.
Thanks.
And that episode of Earl Grey was all the way back in July 2018. So I'm back a year and a half now. So Mike, you're on and we're going to talk about exoplanets, or our favourite exoplanets in TNG. But I thought before we start the roundtable discussion on our favourites, can you maybe update our listeners on our current understanding of exoplanets and like how many there are, where are they, and can we go live there?
Great questions. I mean, let me just start by reminding listeners or sharing with listeners who haven't heard my voice before that Basically, the reason why I am a planetary scientist, the reason why I study exoplanets is because I fell in love with Star Trek as a kid. And Star Trek is all about exoplanets. It's about exploring strange new worlds. And the real amazing thing is that when Star Trek first came on the air in the mid-60s, we hadn't discovered a single exoplanet. An exoplanet just means a planet that orbits a different star other than our sun. And so the writers kind of just assumed that there would be a wild new planet to go and visit every single week. But nobody knew if those planets existed. It took until the mid-90s before we found other planets around stars similar to our sun. And that was sort of getting towards the end of TNG's run. So even all of TNG sort of we had no real idea whether or not there are really exoplanets out there that we could visit, that we could beam down to and walk around and explore. And Star Trek just made this assumption. And the amazing thing is, since 1995, when the first exoplanet was discovered around a star similar to our sun, and now we have discovered over 4,000 exoplanets. I believe the latest confirmed number that I saw was 4,126 confirmed exoplanets. And so what missions and telescopes have given us in the past few decades only is the reality that actually Star Trek was pretty spot on. There is a planet to go and explore every single week if we had that kind of capability.
That's over 4,000 episodes of Star Trek right there, right?
Exactly. So yeah, the writers better get cranking, because I think there's between 700 and 800 only. Yeah.
True.
But yeah, and it is pretty amazing that it actually took until the mid-90s for us to have the ability to even confirm that there are other planets around on other stars. So that's really something. But yeah.
Right. And that's all because of how hard it is to find a planet. When you look out into outer space, the easiest things to see are the bright things, which are the stars. And planets aren't self-luminous. So the only way you can detect a planet is if you had a powerful enough telescope to get reflected light off of that planet. But we're really not quite there yet for our telescopic technologies to actually really get good reflected light off of planets. So the first ways that we found exoplanets were indirect methods, really receiving no light at all from the planet, but noticing the planet's influence on its host star. So the two main methods of finding exoplanets to date are what's called the radial velocity method, which is where we notice the stars wobble back and forth towards and away from us. And as the star is wobbling, its light is either blue shifted or red shifted. That means the wavelength or the color of the light is changing. And the whole reason why it's wobbling in the first place is because the planet exerts a slight gravitational tug on that star as the planet orbits the star. So it's actually sort of making the star make a tiny little wobble or orbit around the common center of mass of the planet and the star, and we can detect this slight wobble in the star's light and infer the existence of the planet. And the second main way that we discover exoplanets is called the transit method, and this relies on the fact that some of the planetary systems out there are aligned in just the right way that, from our point of view on Earth, we can see when that planet crosses in front of its star once per orbit and causes a slight dimming in that star's light. And when we catch those periodic dimmings, we can again infer the presence of a planet. But both of those methods really get no light from the planet itself. It's truly amazing how we were able to cleverly detect these exoplanets.
It's incredible.
It's really cool. Yeah. This is like a Science in TNG episode, isn't it? It's my favourite thing about hosting on Earl Grey. The online encyclopedia, which has called the Extra Solar Planets Encyclopedia, on the 1st of March published some new numbers. And they have confirmed 4,187 exoplanets in 3,105 different systems, with 681 of those systems having more than one planet. And that's only a tiny fraction of the Milky Way sky that we've looked at.
Yeah.
So,
because isn't it right, Mike? I mean, we've been able to detect like 4,000, but it seems likely that there's, millions or billions of planets out there in the Milky Way, right?
Absolutely. We have only been able to search a small part of our galaxy for planets. Really, the best planet finding mission to date is called the Kepler Space Telescope, and it is no longer functioning. But during its almost 10 years in outer space, discovered thousands of exoplanets, but its primary mission only stared at one patch of sky repeatedly, unblinking. And the reason is because you need to stare unblinkingly at a single patch of sky to catch these tiny transits. You don't know when they're coming. And in order to find a planet, you actually need to watch for multiple transits and identify a common period between those transits. Otherwise, it could be some other thing that's passing in front of the star, or the star has a star spot, or is flaring, or something like that. You really need to identify this exact period of all of these transiting events. And in order to capture an Earth-like planet, a planet with an orbit that is as long as the Earth's, well, we orbit our sun every year. So if you find an Earth-like planet transiting, okay, that's great. That's one little dimming of the star. But then you have to wait a whole year for that dimming to happen again. And if you really want to confirm the planet, you need to wait for a second year after that to really find that period to say, oh, the periods between the two, the three different transits, the 2 periods between the 3 different transits were the same. So it really takes a long time to find planets. And so our missions have been most sensitive to planets that are very close into their stars because they orbit and will cause those transit dimmings on a faster time scale, and also planets that are large, like Jupiter-sized planets. So the first planets that were discovered were these hot Jupiters, planets as large as Jupiter that are orbiting with orbital years that are like on the matter of days. So probably
that'd
not
be a crazy planet
planets
to live on. Yeah,
it would be really old.
Exactly. Yeah. And one of the things that I would love to see in Star Trek is a hot Jupiter. I don't think we've seen one of those yet, but
not really.
Yeah, we've discovered so many of them that they're actually pretty common. So getting back to looking for habitable planets, if you want to find a planet that's in the habitable zone, then you have to sort of wait a longer time and take your time with that. So we've still only found a handful of planets in the quote-unquote habitable zone of their stars, but it makes it a lot easier to actually target small stars. Small stars tend to be dimmer, so their habitable zones are sort of shrunk towards their stars, meaning that planets in those stars' habitable zones have shorter orbital periods, and we can find them quicker and then try to analyze them for signs of life and inhabitants.
Mm-hmm.
Wow.
Very interesting, and I feel like we've only just begun, and we're going to learn a lot in the coming decades, it seems like.
Well, absolutely. There was a statistic I read earlier about the number of confirmed exoplanets doubles at something like every 27 months, and now the Kepler is no longer in operation. The James Webb Space Telescope is going to launch next year.
That's our hope.
Supposedly, it's been moved a few times, right?
That's right.
Oh, has it? Okay, so plan is, I think, to launch next year, all going well. And then, given its sensitivity and its ability to look at deep space and take measurements for us, you can imagine the number of exoplanets that we find will just increase vastly.
Right. So I want to make a distinction between the types of telescopes that find exoplanets and the types of telescopes that can actually characterize them and look for signs of life. So Kepler is a great telescope for finding planets, but it actually has no ability to separate the light that it receives in different wavelengths. And that's the capability that we want in order to take measurements of the different types of molecules in a planet's atmosphere. That's the capability that James Webb will be able to give us once it launches. Right now, Kepler's successor, which is named TESS, or the Transiting Exoplanet Survey Satellite, is doing kind of what Kepler did, but for the full sky. So while Kepler stared at this one little patch, TESS is swiveling around and trying to find as many exoplanets nearby around bright stars in every direction of outer space. And again, the telescopes that find the planets are not the telescopes that can tell us whether those planets are habitable. So TESS is like Kepler in that regard, and we'll need other types of telescopes like James Webb again to figure out what those planets are actually made of.
I'm learning so much. This is so cool, yeah. So I take it once like TESS or Kepler find a planet, then we use these other instruments that can look at the light coming from the star and how it's changed as it passes through the planetary atmosphere. Obviously, different wavelengths are going to be absorbed by different molecules and gases in the atmosphere. And so we compare the star's spectrograph with the spectrograph that we get of the light that's come through the atmosphere, and we see kind of what wavelengths are missing, and then infer from that what elements and compounds and gases might be in the atmosphere.
That is 100% correct. Yeah, you would have aced the assignment that I just gave to my astrobiology class yesterday.
Nice.
Yeah.
Interesting. So I didn't do any research on that. It kind of stands to reason. I teach high school physics, so in our higher physics course, which is one of the kind of the second highest course you would do in Scotland in high school, we teach about kind of basics of stellar spectroscopy. And when you were mentioning the radial velocity method, I just taught my higher class Newton's universal law of gravitation, which kind of explains why kind of the planet orbits and the star just does a little wobble thing that it does. So it's so cool. It's so amazing when you can actually take knowledge that you gained from your physics degree or from learning physics or just having a passing interest in science and actually apply it to real world things and apply it to your love of Star Trek. So cool.
Yeah.
Okay, so I did a little bit of research earlier, again, before we go into our favourites. And I was trying to look for a list of Star Trek planets around stars that are real stars in real life that have confirmed exoplanets around them. And I found it was a bit of a tricky task. However, there's a couple of really good examples. I think the one that was maybe mentioned most is Sigma Draconis, which is a real star. And the planet Sigma Draconis 6 was the home of the Morgs and the iMorgs in the TOS episode Spock's Brain.
Oh, wow. I hope if we go there, it's not a culture that tries to steal brains.
I think if we go anywhere, biology will be so different. It'll be like the Alien movies. They'll be weird.
Quite different, yeah. That seems most likely, but,
Yeah, I know. I would like to think there are other humanoids out there. Another one that was mentioned quite a lot was the star Pollux, also known as Beta Geminorum, I think. How you pronounce it. There is an exoplanet that was detected and confirmed in 2006, and it's got a mass 2.3 times that of Jupiter and an orbital period of 590 days. It was mentioned, when I say mentioned, it was maybe on a star chart, on an oculogram, or it was maybe seen on screen or somebody mentioned it. It was on an oculogram in Star Trek 6 in Captain Kirk's quarters on the Enterprise A. It was mentioned again in an Alpha Beta Quadrant overview in the Ready Room of the Discovery in Magic to Make the Sanest Man Go Mad. And also similarly in the War Without and the War Within during the Federation Klingon War. And then in the TNG episode Inheritance, Data is investigating Juliana Taylor. And she's recounting how there was a few people that left on a ship from the Pollux 4 orbital station before she got to Omicron Theta.
That's cool that there are some that you can connect where there's a reference in a Star Trek episode and it does have planets around it in real life.
Yeah, so Star Trek have mentioned that the planet exists, and we now go and find that there is an actual planet there. So it's kind of cool and interesting. I like it.
For sure.
Whether they're not the same type of planet, whether they're not that M-class. And I really hope that when we find habitable planets, we call them M-class planets.
That would be cool.
Like we called the first shuttle Enterprise. I think that would be only fair.
That would be cool. Use all the classifications, yeah.
Let's get into our little roundtable discussion. And Mike, I would like you to go first with your favourite exoplanet seen in TNG, please.
Oh, goodness. So it was actually really difficult to choose. just 3 favorite exoplanets. I mean, there's so many great exoplanets out there. And also, it's interesting because, I was thinking about the planets that we see in TNG. And there's so many cool planets, but then I go back and rewatch that episode. And I'm like, well, this story really has very little to do with this planet. It's definitely about, the crew and the human story and the emotions and the ethics. And I think that's just what makes Star Trek so great. It uses these planets sort of as a backdrop, and the real meat of the story, that real, pull that draws me in is the characters. But I did pick 3. And do you want me to say all 3 of them right now, or go one by one?
Oh no, you're not allowed. You just have to go one.
Oh, just go one by one. Okay.
Oh, yeah.
Well, okay.
To keep us in suspense.
Yes.
Okay. Well, I think we have to start with planet Vulcan. So Vulcan makes 3 appearances in TNG in the episodes Sarek, Unification Part 1, and Gambit Part 2, and is obviously the homeworld of the Vulcan species. And when it's depicted in Star Trek, it's sort of this rusty red world that sort of resembles Mars, except we know that it's much bigger than Mars because it has a higher gravity than Earth, and that's why Vulcans are supposedly physically stronger than humans. And it's got a really cool story behind it, that in Star Trek lore, it was always said that Vulcan orbited a star in the constellation Eridanus, which you can actually see in the southern hemisphere. So unfortunately, all 3 of us live in the northern hemisphere. But if you're a listener and you're in the southern hemisphere and you look up at the night sky, you can actually see the star that Vulcan is supposed to orbit. And originally, that star was Epsilon Eridani. And today, we actually know that the star Epsilon Eridani has not 1, but 2 debris disks or asteroid belts in that system, and perhaps 2 planets. And we can infer the existence of those planets by sort of their gravitational effect on the debris disks in those systems. So the debris disks aren't like a uniform disk. They're sort of clumpy or have some unevenness to the distribution of the dust in that disk. And that could be the result of gravitational tugs of planets in the system. So that seems like it's actually a really great place for a real life planet Vulcan. But there was a big problem with this star system that Gene Roddenberry actually found out about and did something about. So the problem is that astronomers measured the age of this star and figured out that it was between 400 and 800 million years old. Now, 400 to 800 million years seems like a really long time for you and me, but it's actually a really short amount of time on planetary timescales. And to just compare that with the history of the Earth's age is about 4.5 billion years old. And for the first 500 million years, Earth was basically hell. In fact, the scientific term that we use for this first period of Earth's history is the Hadean epoch, like Hades from Greek mythology. And then the next 1.5 billion years of Earth's history had no oxygen in the atmosphere. We know this from the rock record. We can examine the chemical compositions of the rocks and see that there's no presence of oxygen in the atmosphere. And then the next 2 billion years bring us up to a full 4 billion years of Earth's 4.5 billion year history, had no animal life forms. There were definitely microscopic life forms all over Earth, but animals only arose in the past about 500 million years of Earth's history, and then we only emerged on the tiniest sliver of time at the very end of all of Earth's history. So it took all of that time, 4.5 billion years of planetary and biological evolution, for human beings to arise on our planet and really to prepare our planet for us to evolve and flourish here. And so again, the Epsilon Eridani system being 0.4 to 0.8 billion years old, right? Less than a billion years. When Gene Roddenberry realized this, he knew that there was a problem. In fact, he even went on to write in Sky and Telescope magazine in the 1991 issue, so this was right in the middle of TNG's run, that life on any planet around Epsilon Eridani would not have had time to evolve beyond the level of bacteria. And I think that's bad enough news that it would make any Vulcan cry, right? It's just like, there's not enough time to evolve anything beyond the level of bacteria on this planet. So Gene Roddenberry switched the star that Vulcan orbited to a different star in that Eridanus constellation named 40 Eridani A. And he chose that because 40 Eridani A is about the same age as our sun, meaning that any planet around that star would have had the chance to evolve complex, intelligent life forms like Vulcans. But the thing is, of course, he didn't know if there were any planets around 40 Eridani A, but just 2 years ago, astronomers discovered a planet around 40 Eridani A. And it's a planet that's about 8 times the mass of the Earth and has an orbit 42 days around its star. So this planet is probably not exactly like Vulcan because it's a little too close to its star, that it's probably too hot for liquid water to exist on its surface and therefore not be capable of hosting life as we know it. But there may be other planets in the system. Remember, it's easier to find the close-in ones, and maybe given more time, we'll actually discover planets in the habitable zone of 40 Eridani A, and maybe one of those will be hosting a civilization of pointy-eared, green-blooded aliens. So I'm looking forward to follow-up observations.
If it does, we'll definitely have you back on Earl Grey to talk about that.
Excellent.
Yeah. We'll have everybody on Earl Grey to talk about that if it's true. I like what you did there, Mike. You kind of burst everybody's bubble about Vulcan not being able to exist because the star was too young, and then you blamed Gene Roddenberry, and then you saved us all and said they moved it to a different star. So
it's just really amazing how much thought Gene Roddenberry and really all of the Star Trek writers and producers since him really care about the science and getting it right. And this is just one example of when the science came down that, this star is not suitable for Vulcan. Gene Roddenberry just switched it. He said, I'm the creator of Star Trek. I get to decide where Vulcan should orbit. It should orbit this other star because that's much more plausible. So, yeah, it's really cool.
I think that's one of the reasons why I fell in love with Star Trek as well, because I always had a fascination with the science. I think that's one of the things that one of the reasons why I fell in love with Star Trek is because of the science. I always had this kind of fascination with anything that was scientific or electronic or anything that I didn't really understand. So I remember it must have been back in 1986 we got our first Betamax video recorder. Remember we used to get VHS and Betamax were another. Did you guys get Betamax?
Well,
No?
I was probably too young to really deal with the different formats. I only remember VHS, but
So
I know there was
VHS
a big thing in Betamax.
Yeah, big.
Went away.
And Betamax were like
Bigger.
And my parents went with that. And then Betamax kind of failed as a format. But I remember when we'd got it, they must have spent hundreds and hundreds of pounds on it. And the first thing I did was get a screwdriver and open it up and take it apart just to see what was in it, because I was fascinated with this. Maybe one of our first pieces of electronic gadgets that we had besides our TV in the house.
I can imagine they weren't happy that you took it apart.
Do you know what? I was a really skilled 9-year-old, so I managed to put it back together.
You put it back together?
It still worked. Yes, it still worked. There were some screws left over, which I figured were just kind of extra. Free screws you got with it. I think the next thing to go was the microwave oven, because we never had a microwave oven before that. And I was like, whoa, this is magic, this machine that can heat your food up. So yeah, I really appreciated the fact that the science in Star Trek always, it felt right, even though I maybe didn't understand it. And then I had knowledge that they had science consultants on, kind of making sure most of the details were, if not right, or made them believable in a way, and that kind of half fit our current understanding of science. Justin, what about your first choice?
Yeah, it's interesting. It actually wasn't too difficult for me to come up with a list because we probably have different reasons for loving things, but the first one that came to mind for me was Betazed. It's a really beautiful planet. I love, that it's the home world for, Troy's heritage and for Lwaxana Troi. We only really see it in one episode, Menage a Troi, when you see Riker and Troi there, and they're just, taking a walk, going through all the beautiful places. But I wanted to talk about it a little bit. I mean, there actually isn't a lot that we know about it, but it just, like, you see the view of it, and it seems like it's kind of this beautiful kind of blue planet. And I think we get like little descriptions, like it actually has a pretty varied climate. It has jungles and canyons and cliffs and continents and lakes. And I mean, it almost seems like it's very Earth-like, but maybe even like more kind of green and lush. So I don't know. I was looking at these things like aesthetically when I'm looking at a planet. Okay, one of my choices is going to break this, but generally, like aesthetically, when I'm looking at a planet, is it one that I'd want to visit or take a vacation on? And Betazed definitely seems to be that. So that was my choice.
Nice, I like that. I think there's a lot of really good examples, given the fact that the Federation is technologically advanced and they can terraform planets and kind of make them as idyllic as they want. Then a lot of the Federation planets will be kind of nice and habitable and suitable for us to go and live on.
Maybe, but I think even with the resources the Federation has, terraforming can be a long process. Like that first season episode of TNG Home Soil, it's taken them decades to terraform this one planet, right?
Planets are really big places, yeah.
Yeah, and there's a lot that you need to do. And like interestingly, I was I've been really enjoying the Starfleet Corps of Engineers novellas, and one of them has to do with this guy that's trying to terraform Venus, which is like the hottest planet in the solar system and has like a terribly toxic, dense atmosphere.
Sulfuric acid clouds, yeah.
Yeah, and stuff like that. And it's talking about like this huge project that even with the Federation's resources is going to take a long time. They're trying to do all this crazy stuff to terraform it. So I think it would still kind of take a lot. I get the feeling that Betazed is a planet that's kind of always been like that. But
yeah, you do get that impression, yeah. Why would you want to terraform Venus?
There's actually a specific reason within the story. It actually relates back to the first season episode with the Binars 11001001, like where they have this issue with their homeworld's computer, and this for some reason in the story, like this is the place that they want to relocate them. So it goes into it. It's a pretty interesting story actually, but just like trying to take on that challenge. But you're right, they probably have the resources to do a lot of terraforming and make the planets into something really great. But Betazed, it just like it's that little scene. I want to go back. We've never gone back. We've just had references. I just want to go back and see what it's like. Hopefully, if you see it in Picard, it'll have recovered from the Dominion War. But yeah, I just ever since I first saw it, I'm like, that looks like a wonderful vacation spot. I want to go there.
Yeah, absolutely.
That's what I was thinking about. Not any real life planetary implications like you make.
Okay, so I think for my first pick, not necessarily a place that I would want to go, but that I'm nonetheless fascinated with, is Andoria.
Do we reference it? Is it even referenced in TNG?
Oh, it has to be TNG, doesn't it?
Yeah, I thought about that one, but it's really Enterprise. You want to pick another one from your list?
I love Andoria too, so I don't mind talking about it, but I don't think we saw it in TNG at all.
Or even referenced
Can I leave it as a special mention? I can't believe I failed at my first attempt. It's ridiculous.
That's okay. I thought about that and I was like, yeah, there's like an Andorian in the background of Captain's Holiday or something, and then Lal has this supposed Andorian, but you don't really... TNG is not the Andorian series, unfortunately.
It's not.
I mean, maybe I can give you an exception because there's like an Andorian in the background, but...
No, Data's Day. They talk about wedding. Data is trying to come up with the whole wedding thing and looking at different cultures. And he mentions Andorian weddings.
We'll give you a pass, even though we don't see the planet in TNG.
Yeah, it's too cool not to talk about a little bit.
It's too cool and too cool.
Too cool.
Good one.
Talk about it, it's fine.
So the reason I've picked Andoria is because it's mentioned by Data in the episode Data's Day, which is one of my favourite episodes. Interestingly, Andoria is not a planet. It is a moon around a gas giant, and it's frozen. And a real-life analogue to that is Saturn's moon, Enceladus.
Oh, so not only is it just a reference, it's not even a planet. Joe.
It's not, well, they don't have to be real planets, do they? However, the home star to Andoria is Procyon. Mike, does Procyon have any exoplanets?
I have no idea.
Given your encyclopedic knowledge.
I mean, come on, you don't have all 4,000 and something cataloged in your head.
No, definitely I do not. And they all have terrible names too. They're all like HD 189588B. It's but sorry, I do not know if the star Procyon has a planet around it, much less a planet with a moon. But I do love the concept of Andoria, specifically for that reason, that within our own solar system, so undoubtedly in countless other solar systems as well, there may exist habitable moons of gas giant planets. And so, Joe, you brought up a really great example, Enceladus around Saturn. There's also Europa around Jupiter. And both of those are targets for future astrobiology missions to actually go and try to find out what's underneath their icy shells. And we suspect that there is global oceans of liquid water beneath both.
Maybe there are Andorians living under the ocean on Enceladus. Okay, probably not, but
maybe
Justin.
Yeah, but so there has been some scientific speculation about people try to constrain the amount of energy that is in those systems, in those subsurface systems, the amount of nutrients as well, and come up with what is a plausible biosphere there. And for Europa, there is enough oxygen down there that it could possibly support animal-like life. And the reason why there's oxygen there is because it's created on the ice shell by radiolysis. So all this dangerous radiation is hitting this ice. Ice is water, H2O. And if you pop off the H's from H2O, and H being such a light atom, hydrogen atom, just flies away into space, you're left over with a lot of excess oxygen. And that oxygen might be able to eventually subduct into that ocean and supply a really good, source of essentially quote unquote air, for something to breathe. And that's something that every life form needs, is an analog to oxygen, if not oxygen itself. So it's cool that it's being created in that way on Europa.
I'm so glad my pick actually turned out to cause so much discussion and be such a good choice. Another interesting thing about Enceladus, even though it's way outside the habitable zone of the sun, the temperature of the subsurface oceans can be something like 200 degrees higher than the surface ice because, they think because of it's something like gravitational flexing or something like that. I think the analogy is when you get a stress ball and you squeeze it, the friction will cause it to heat up. Enceladus does a similar thing because of its orbit around Saturn and starts to get a little bit hotter than it actually should be.
Yeah, we call it tidal heating. Essentially, the planet is on a slightly eccentric orbit, which means its orbit is not exactly circular. It's more like an oval. Yep. And so when it gets closer and farther away from Saturn, it'll deform different amounts due to Saturn's gravity. And that flexure, as you said, deposits heat in the interior as friction. And that's what heats these planets.
So it's like the stretchy ball planet.
Yeah.
Exactly. That's actually another name for it. Cool.
Okay, very cool.
Thanks, Justin. Okay, Mike, let's do round two. What is your second pick for favourite exoplanet?
Okay, my second pick is the planet Remus from Star Trek Nemesis. That counts as TNG, right? Because it's a TNG movie.
Oh, yeah, absolutely.
Okay. Yeah, absolutely, yeah.
Awesome. But it is definitely not one I thought of.
Well, I love talking about Remus because it's a great example of a tidally locked planet. So what is a tidally locked planet? Tidal locking is a state where an orbiting astronomical body, like a planet orbiting a star, always has the same face facing the object that it's orbiting. So Remus has a day side that is permanent day side and a night side that is permanent night side. Another really good example of tidal locking is the Earth and the Moon. The Moon always has one side facing the Earth, which is why we always talk about the dark side of the Moon very poetically. Like this mysterious place because we never see it from our vantage point.
But it's not actually dark all the time on that side.
That's right. Yeah. But for Remus, there is one side that is always dark and one side that's always bright. And because of that, the day side is scorching hot and the night side is frigid. And the Remans are depicted to live basically underground. They're miners. They're trying to extract dilithium from the deep interior of this planet. But also, I think that's just the only place for them to live because on their planet, they couldn't live anywhere on the surface. And so it really gets you wondering, are all tidally locked planets? And there's a good reason to suspect that there are a lot of tidally locked planets out there, because what causes tidal locking is essentially the force of gravity, which acts upon all systems. So in systems orbiting where planets orbit small dim red stars, again, as I said earlier in the podcast, to be in the habitable zone of those types of stars, you need to be very close to your star because the star is less luminous than our sun. But when you get super close to your star, the star's gravity causes your planet to actually enter a tidally locked state. So it's very likely that a lot of the planets in the habitable zones of these small dim red stars are actually also tidally locked. And so as a planetary scientist looking for signs of life, that's really concerning because I know of this amazingly depicted tidally locked planet in Remus, which is uninhabitable on its surface. And I'm like, oh no, are all these planets in real life going to be just like Remus? But it turns out there is something that could save these planets in terms of making their surfaces more habitable, and that's giving them a sufficiently large atmosphere and an ocean. And so if you give a planet an atmosphere and an ocean, and Remus is depicted as basically an airless body, it's just, it's got nothing on its surface, it's just bare rock. But if it did have an atmosphere and an ocean, it might be able to redistribute its heat from that bright, hot perennial day side to the cold, dark night side and sort of even out the heat around the planet. And we know this because that's what our atmosphere and ocean do on Earth. Basically, our equator gets more energy from the sun than our poles. So the atmosphere sets up these giant convection cells that sort of transports heat from the equators to the poles, making our poles less cold than they would have been otherwise. They're still pretty cold, but they're habitable, right? And I just asked the penguins or the polar bears, right? They're fine living there. So planetary scientists can solve the same physical equations that govern the motion of Earth's atmosphere and Earth's ocean for the case of a tidally locked planet. You're just changing the state of the planet to say it's not going to rotate with respect to its orbit around its star. What do the equations spit out? And they spit out circulation patterns that essentially take that heat from the bright, hot day side and bring it to the night side. And what you get in a lot of these simulations is what's called an eyeball planet, because the bright day side is essentially a temperate ocean where there's a huge amount of evaporation of that ocean, causing a mass of clouds to build up on the day side. And the clouds actually reflect the light back to the star and keep that day side from overheating. And the ocean and the atmosphere then transport heat to the night side. And although the night side in most of these simulations is still very, very cold, it can be habitable for life forms that enjoy cold temperatures. So, it's going to be exciting to see whether or not these tidally locked planets are possessing of an atmosphere and an ocean and could possibly be habitable thanks to those attributes, or if they are more likely to be bare rocks like Remus, which they might many of them might be, because they're again very close to their stars, and so they might have suffered a lot of radiation early on that stripped away their atmosphere and their ocean, the way that it apparently happened on Mars. Mars is sort of this cold, dry desert world right now because it lost most of its atmosphere and any water that it had on it very early in its history. So, yeah.
Oh, cool. I have a question related to tidally locked planet, because I don't think we've seen it in on-screen Star Trek, but I think there are some parts in the novels where they will talk about something that's tidally locked, where it's, really scorching hot on one side and super, super cold on another side. But they'll talk about people living in, I guess what you call the Terminator, which is like the kind of boundary between the two, like in a little like kind of gap area there. Mm-hmm. Does that seem like it would be, I mean, you talked about like having, even if there isn't an atmosphere, to have just, I don't know, like domes or like something they could live in where maybe it wouldn't be as difficult to regulate the temperature because it's kind of in between? Or is that not a thing that would matter?
Yeah, that's definitely a great idea. Indeed, if there were to be a habitable region on this tidally locked planet, on the surface of the planet, it would be along that Terminator. The thing is, when we look for signs of life using telescopes today, we really need there to be a flourishing global biosphere to create the types of biosignatures that we can observe from afar. And if it's a very confined biosphere, either to the subsurface, like the Remans live in the subsurface, or just along this thin Terminator, it may not actually create that noticeable of a signature for us to look and find. But there is an example of a tidally locked planet in TNG that is habitable on the surface of the planet, and there are like two different civilizations, one that lives on the day side and one that lives on the night side. I think this episode is called the Dauphine. I hope I'm pronouncing that right. Dauphin, yeah. Planet's name is Daled 4, and if you go back and rewatch that episode, which I did many months ago now, so my memory's a little hazy of it, but I think it's like Wesley Crusher, and there's this princess from one of these planets, and from this planet, and she's from one of the sides, and she needs to broker a peace deal with the civilization of the other side. But anyway, that's a habitable, tidally locked planet, and probably has an atmosphere and an ocean that keeps both sides habitable.
I'd forgotten about that. Oh, and that's also the one with the elastomorphs, the kind of changeling-like creatures that
exactly
turn into different kinds of things. Oh, that's cool. Wow, like I hadn't even thought about Remus when I was making this list. Interesting.
Question though, I know like Star Trek lore has always depicted Remus as being a planet, but the way they visually show it in Nemesis makes it seem more like a moon around Romulus. I mean, the way they zoom out of like Romulus and they're like instantly at Remus.
They do that all the time in science fiction and especially in Star Trek, where when you're on one planet and you look up at the night sky, there's this giant other planet just looming there. And yeah, it's probably just, that's for artistic effect. I've seen star charts, shown on screen of the Romulan system. Remus does have its own orbit around its star. It's supposed to be the third planet in the system, and Romulus is the second, I believe. And that's a little bit puzzling to me because, again, it's the force of gravity of the star that causes the tidal locking. So if Romulus is actually interior to a tidally locked planet, you'd think that Romulus would be tidally locked as well, but it's not. So that's a little puzzling to me, but there's some ways out.
Some special subspace effects or something.
Yeah.
Is Mercury tidally locked? Or can you get partial tidal locking?
Yeah, Mercury's a sort of special case. I think it's in a 2 to 3 resonance, spin orbit resonance. So another name for tidally locking is synchronous rotation, or a 1-to-1 spin orbit resonance. That's technical jargon that just says that the planet rotates. It does rotate. It rotates exactly once. It makes one rotation every time it makes one orbit around its star. And so it's a 1-to-1 spin orbit resonance. I think Mercury's in the 2 to 3 or 3 to 2. I can't remember exactly, but it's another class of this general idea.
Okay, so for every 3 days on Mercury goes through 2 orbital periods around the sun.
According to Wikipedia, which is a planetary scientist's best friend, Mercury is tidally locked with a 2 to 3 spin orbit resonance. So it spins 3 times every time it orbits twice.
Yeah, and the orbital period is 88 days, it says. So
interesting. Okay, Justin, your second pick, please.
Okay. Yeah, so you'll detect a theme in my first two picks. It's so interesting because you guys are picking ones that are interesting for other reasons. I'm picking like vacation destinations. So
nice.
My second one is Risa.
Nice.
Yeah, like yes, it's like TNG's Pleasure Planet and all of that. But I know like things always go wrong for almost everyone except Hoshi and Enterprise every time that they go there. But I'm going to go there when there aren't problems because Memory Alpha actually has a lot of information. We actually go to Risa like 5 times or something like that, I think, which is kind of crazy. But it was first seen in Captain's Holiday in season 3. And we're told that it was originally kind of this dismal, rain-soaked, geologically unstable planet that had lots of, jungles and earthquakes. But the native Risians there kind of transformed the planet, and they have this weather control system. So basically it just kind of always has perfect weather, and they've regulated their earthquakes and all of that. So it's kind of this like ideal vacation spot. And you actually get mention of like a lot of different places on the planet. And I think when we see it, it's kind of like these beautiful beaches and blue oceans and palm trees. I mean, it's kind of like Hawaii as a planet almost. But like there's a lot of different areas that are referenced. There are gardens and different pools and recreation parks, and I just get this feeling like this would be like a really cool planet to go to. I mean, regardless of it being the Pleasure Planet and all of those implications, but I just like the idea. I mean, we had this in the original series with the Shore Leave Planet, like a place that's there like as a tourist destination, really, right? Whereas my first pick, Betazed, like it's less of a tourist destination, but the Risa is, and if it really existed, I would definitely want to go there and take a vacation. I think it would be a lot of fun. I don't think, Mike, there's necessarily anything interesting they mention about like how it orbits or anything like that, but it just seems like a really cool planet. So I'm making my Star Trek vacation list, Betazed and Risa.
That's awesome. I had Risa as a honorable mention, so I might as well just mention it here. Uh-huh. It orbits 2 stars, so it's in a binary star system. And so it's a little bit like that other planet from that other sci-fi series, Tatooine in that way. But yeah, it's cool that nowadays we actually know of planets that orbit binary stars. And again, it's we've yet to see a evidence of a habitable planet specifically, but the people can actually theoretically derive habitable zones around.
It's more complicated though when you're dealing with the gravitational pull of 2 stars potentially, right?
Right, exactly. It gets very much more complicated when there are 2 stars, and that means that the climate regulating feat that the Risans did for their planet to keep it perfect throughout the entire year is just even more amazing, because they have to deal with 2 suns that are orbiting each other, and sometimes one sun is probably blocking the other, and so in that case you got to ramp up the temperature on your planet. Yeah, it's amazing.
Yeah. Okay, cool. I never even noticed that it was orbiting like in a binary system. I just noticed what a beautiful place it is.
I had Risa as my second pick also, purely because of the whole vacation thing. You could go anywhere and it would be completely idyllic. The weather would never kind of cause you any harm, like what Earth's weather has done in Scotland over the last 3 weeks.
Oh no!
Yeah, you need a weather regulator sometimes. So.
Yeah, I think so. It's been pretty miserable. So for my second pick, can I pick one we've never seen on just because of the way I imagine it?
What do you mean? Is it mentioned in TNG?
Well, yes. Well, no, it is. It is mentioned. You've just never seen it. So I'm going to pick the Binar's homeworld. I know you mentioned the Binars earlier, because of how I imagine their planet being a bit like the way Coruscant was Is that the Star Wars place? The galactic capital with giant skyscrapers made out of like liquid metal.
Don't look at me. I'm not the person to ask about Star Wars stuff.
Space elevators up to their moons and just really technologically advanced, like a technological marvel of a planet.
Mm-hmm.
And I think that'd be really cool to go there and visit. And that'd be really tall, so because the binars are really short.
Okay. Lots of technology and Joe, the tallest person on the planet. That's why you'd want to visit. Okay. But yeah, like I've always imagined, since they have like this massive computer that's kind of running their planet, and like I guess in a way all the binars are connected through subspace to this computer as well, that it would just be almost like this kind of marvel in itself that would take up like a substantial portion of the planet, is almost how I imagine it.
I think so, yeah. If not all of it, or would they?
It's just one giant computer. How did they evolve?
They seem so... Well, it's maybe a bit like what the Borg did to Earth when they assimilated it in First Contact. Like, I saw this really cool artist's impression of New York post-assimilation, where like they've assimilated the Statue of Liberty and there's a big kind of red laser kind of ocular implant thing.
They've actually changed and assimilated like a non-organic being, just like a statue.
Yeah, like as an effigy of the Borg kind of thing.
Wow, that's
and it was just a really interesting look at what the Borg might do to the planet. Like, you can't really see much of the Hudson because they basically kind of covered it over with buildings and things like that. So
you have some really interesting picks today, Joe.
Yeah.
A planet we haven't seen, and one that's just okay. Yeah.
So let's move on to our third round then, and hopefully I can pick a planet that exists this time.
I mean, these exist, but we don't really see them in TNG.
I know, it's like you with time travel.
Hey, I haven't done anything like that since. So.
I know, but it's always going to come up. Mike, go with your third pick, please.
All right, my third and final pick is the planet Atria 4 from the season 7 episode Inheritance. And this was an interesting planet because the premise of the episode is that they've arrived at this planet, which is getting a lot of seismological activity that is making the planet uninhabitable. And the reason why there are so many earthquakes on this planet is because its core is solidifying. So planetary interiors sort of look like an onion structure. For Earth, we have a solid inner core of iron overlain by a liquid outer core of liquid iron, overlain by this giant rocky silicate mantle, and then our thin little crust, and then our little hydrosphere and our atmosphere. And so a lot of our planet is actually molten on the inside because it's so hot. And this molten outer core of iron is apparently what is solidifying on this planet Atria 4. And when things solidify, they tend to contract, and then that is propagating throughout the entire planet and causing the crust to crack and have giant earthquakes. So the premise is that the Enterprise needs to come and save the day. They're going to essentially shoot a phaser into this planet and reheat the core to reliquefy it. And that's a really interesting idea. So I decided to do a little back of the envelope calculation. I wish Amy were here because, I did some math this morning for her.
She could check your math, yeah.
Yeah, she could check my math. But yeah, so basically what I did is I said, okay, let's imagine that this planet is basically like Earth. It's got an outer core of a certain volume, and all of that has frozen solid. And we want to melt it. So I took the latent heat of iron, because that's what the core is mostly made out of, and I figured out basically how much energy you would need to deposit into this core to melt an amount of iron that is equal to the volume of the outer core. And I got a huge number, of course, because it takes a lot of energy to melt something so ginormous. And then what I did is I was wondering, okay, so can the Enterprise actually do this? And so I said, what is the Enterprise's power source? It's fueled by antimatter. And so I calculated how much energy, how much matter. So, okay, well, let's back up. What does it mean to be fueled by antimatter? Basically, you've got some antimatter and you've got some regular matter. When they meet and they touch each other, they just completely explode, and they convert all of their mass into energy by Einstein's famous equation, E equals mc squared. So that actually gives us a really easy way to calculate the mass of antimatter and matter that you need to combust to get the amount of energy needed to melt this core. You just set the amount of energy needed to melt the core equal to mc squared. If you divide both sides by the speed of light squared, c squared, then you get the mass of antimatter that you need to do this. And when I calculated this out, I got that you need a mass of antimatter about 1,000 times the mass of the Enterprise D. Hand wavy order of magnitude back to the envelope calculation, but you basically need to have 1,000 times the Enterprise D of an antimatter reaction. And obviously the Enterprise D definitely doesn't have more than 1 times the mass of the Enterprise D worth of antimatter on board. So it seemed like a little bit of a ridiculous thing. But I was reading in this Star Trek science log book that Andre Bormanis, the science consultant for TNG, wrote, and he actually had a little snippet about this episode and said, yeah, that was a little bit unrealistic, but you can imagine that phasers, which are made of nadion particles, can start some sort of chain reaction in the planet because, nadions, they're who knows how they work. And so that's the way they explained it in that book. But yeah, it was a fun little calculation to do, and really shows you how large planets are and how much energy you would need to melt a core.
That's really cool that you did that calculation. Like it's always struck me whenever you have these things in TNG where it's like the Enterprise is going to come by and fire some phasers or some beam and the whole planet is going to be like, it seems much more realistic that like if you really wanted to change like a whole planet, you would have a fleet of like thousands of ships around the planet, like all firing at once or something like that, and then maybe you'd have enough energy. But like one ship has always seemed like, okay, like I'll just wave that aside. But yeah, your calculation confirms it. It's too much.
Yeah,
absolutely.
Yeah, the only other thing that I wanted to say about this planet, is that it really hits home the point that planetary habitability isn't just about this thin exterior of the planet. We talked about how an atmosphere really helps, but even that is also just this thin little portion of a whole planet. What goes on in the interior, the deep interior of the planet, and the core actually really does influence the habitability of the surface. And the Star Trek episode illustrates one way in which it could happen, this catastrophic event where the entire core freezes up and the planet sort of contracts and cracks and has a bunch of earthquakes. But another thing that would happen if the core of the Earth or any other terrestrial planet froze is that we would lose our planetary magnetic field, because it's the convecting motion of the iron in the outer core, thanks to its liquid nature, that generates our planetary magnetic field, which shields us from all sorts of harmful radiation from the sun and from outer space. And so if we had a solid core, like perhaps Mars does, and Mars doesn't have this giant magnetic field that protects it, the atmosphere would be much more easily stripped away, and we would receive a larger dosage of radiation here on the surface. It's all thanks to what's happening, thousands of kilometers beneath our feet that we can owe our existence to.
Mm-hmm. Yeah.
That is depicted in the movie The Core in 2003,
Indeed.
where the Earth's kind of outer core does indeed start to freeze up, which causes the magnetosphere to collapse, and then it makes all the pigeons go crazy. I think, is there not a scene where the Golden Gate Bridge starts to melt because of energy from the sun? Was that a different movie? But I'm sure all the science in these movies is totally spot on. So that's cool. Yeah, people.
No, it's not.
Of course, the bridge would melt.
Not in the slightest. Yeah, that's really cool. So, Justin.
Yes, it is my turn for my third pick now.
for your third pick, please.
Okay. I said this one was going to be different because this is really not a vacation spot, but I think it's a really cool planet. And it's not a fan favorite episode, but I love the episode.
You better not pick my planet. Don't pick it.
I kind of doubt it. So it is Theta 8 from the Royale, which is the so I mean, a lot of people know it as the episode where, implausibly the planet is uninhabitable, and we'll talk about why, like on the surface, but implausibly, like there is this simulation or something that these aliens had set up for this 21st century astronaut that was, taken away from Earth or something like that to this system, and he has to kind of relive this life from this like terrible novel. It's that episode. I actually really love it and think it's a lot of fun, but I'm picking it because I think it's really interesting and not the kind of planet that you often see in TNG. So according to Memory Alpha, it's uninhabited eighth planet of the Theta 116 solar system, orbital period of 832 days, rotational period of 15 hours, K-class Transjovian planet, atmosphere composed of 57% nitrogen, 23% methane, 14% liquid neon, 2% urium, 2% chemium compounds. They've made up some of this stuff. 1% ethane and trace tormium. Average surface temperature negative 291 degrees centigrade with wind speeds up to 320 meters per second. And it also has ammonia tornadoes. I think I tried to do a calculation. Like, this is like a really terrible place to live, right? But I think I did a calculation, but like the wind speed of 320 meters per second, I think is something like 1,100 kilometers per hour, just like crazy stuff. But like, I really like that this is an unusual planet that is, filled with kind of all of these gases, like lots of methane and lots of liquid neon and other stuff. And it's extremely cold and really high winds and these ammonia tornadoes. I just kind of really love that we got a planet that has those things, even if it's going to be like last on my vacation list.
Yeah, it's just a wacky planet, isn't it? With all the science thrown in there. And the fact that it's colder than absolute zero, so it's not physically possible, at minus 291 degrees Celsius.
That's what Memory Alpha says. I'll have to check the script to see if that's what... But what's absolute zero? Is it negative 273 or something?
5?
Subspace stuff makes it...
Minus 273.15 Celsius.
I didn't even think about that, but yeah, it's that cold. It's even below absolute zero, which is impossible. But yeah, so there's like a lot of wacky stuff that they throw in there. But and like when they go to the planet, it's kind of like you see the away team and there's like this dark corridor, and then like above them are like green clouds just like whipping by. I just think there's something, I don't know, just really cool about it that I like, and that there's this weird casino simulation inside of it.
But not somewhere you would want to go, no?
I don't think it's somewhere I'd want to go because, like, first of all, it's uninhabitable except for this pocket, and even within that pocket, you get caught in this like bizarre casino simulation. I love the episode, but I don't want to get stuck in that place.
No.
For the rest of my life and like die in bed like that poor astronaut. Yeah. So it's kind of a weird episode, but I've always liked it, and I've always noted like that's a lot of detail and a really odd thing for a TNG planet. So
yeah, I will note that this planet, whose primary constituents of the atmosphere are nitrogen and methane, that's very similar to Saturn's moon Titan, which has a nitrogen-dominated atmosphere with a lot of methane in it. And the methane and nitrogen chemistry actually produce a lot of really interesting organic molecules that some people think are maybe analogous to prebiotic chemistry on Earth, or at least could lead to a very new kind of exciting complex chemistry that could lead to life as we don't know it. Yeah, that's a cool connection there.
I mean, they do, I think, say somehow in the episode that these aliens did something that like put this astronaut like way off course, like many light years away, and they were trying to do something and they couldn't return him, and were trying to do something to make his life better. So maybe they did actually evolve out of this planet somehow. I don't know. But I checked back in the script. I think LaForge does say that it's like surface temperature minus 291 degrees Celsius. So that's a mistake. But it's really cold. It's really cold.
Yeah, I think you just get the point that it is really cold, yeah. That's cool. You definitely don't want to go there because you might get shot by Mickey D.
That's right. There's something that's just like so like bizarre and surreal and like campy about the episode that I really love. It's actually one of my favorites in the first couple seasons, but I think the planet's really cool. Yeah.
So for my third pick, I think, you know that way when you go to STLV and you come back and you've got the con crud, or you just feel about you've drank too much because you've been at the bar
on both counts, sorry.
4 a.m. So sometimes just like you come back from holiday or vacation and you need another vacation to recover from your vacation. Yeah. So I would go to the planet that would heal me, and that is Baku.
For your metaphasic radiation therapy.
I would go there and feel youthful again. And it just seemed like when I retire, I would quite like to go there just to kind of chill out and be at peace and be at one with nature and just slow down. Don't do life at such a frenetic pace. Just learn a new skill. Learn, what is it they do? Tapestry or pottery? I would learn pottery. I would get myself a pottery wheel and a kiln, and I would make vases. I would do pottery. That's what I would do.
You know, this was on my honorable mentions list because it's a beautiful planet. It's also really interesting because it has rings around the planet, which we don't see, I think, quite as often for planets in Star Trek. So yeah, it's beautiful, you know, with all the plants and the lake and, you know, all the stuff that you see. It's yeah, I think it's great, except for, you know, the conflict that's happening there. But you can imagine you go there before that or something, and maybe it's more idyllic. But yeah, that was.
I wonder where would you know where they filmed those scenes on Baku? I always get the impression, while I've never been, that it's somewhere in the Rockies. Now, like Colorado way, where you get the mountains in the background, and there's like it's low enough down that you get nice vegetation, and there's icy lakes and.
Yeah. So here's the information. Locations used for the film include Lake Sherwood near Thousand Oaks. I actually used to live near there. And the mountains above Lake Sabrina and the Sierra Nevada. So it was some different part. And that area, Lake Sherwood, Thousand Oaks, it's about an hour north of LA, but very like green and pretty kind of area. Okay. And then it's in the Sierra Nevada toward the mountains toward Nevada. So, but it is pretty wherever they filmed it. Yeah. Nice. What do you think about the Baku planet?
Yeah, I think that it's really interesting that it's within the Briar Patch, which is this nebula full of what was the gas called? Was it like Metreon? Pockets of Metreon gas. Yeah. So. You know, I wish you all the safest of journeys getting there. Don't run into any Metreon gas. But yeah, it's striking for its rings, for sure. And I think what you were just saying, though, about filming location is that the coolest planet in Star Trek is almost certainly Earth, because all of these different planets, these wild different environments.
So far, it's all been filmed on Earth.
Yeah, but we have what's really cool, and I guess what might be a mistake in a lot of sci-fi, honestly, is to paint planets as these monolithic kind of everywhere on this planet is either a desert or a forest or ice or, you know, an ocean. Yeah. Whereas we see this grand diversity of different kinds of ecosystems and environments and habitats here on Earth, and we can go to those and actually pretend that that's another world. Like Iceland, for instance, is always, you know, a hotspot for filming extraterrestrial scenes, and I think Discovery has gone there for season 3, right?
That's right. Yeah.
So it's cool that, you know, Earth contains all of that diversity within it, and really makes our planet very, very special. So I think the coolest planet in all of Star Trek has to be Earth.
And that's a really great point and important to think about, like whether it's Earth or another planet in our solar system or outside of our solar system, like what you're seeing is Earth. And there are, you know, times when things are changed, like in the Discovery episode where they like did CGI to make like all the leaves blue, that kind of stuff. But, you know, or they built something on a set or whatever. But like it's really what's within our capability here on Earth to imagine things. And they've been able to imagine some pretty amazing things. Yeah,
absolutely. I did want to pick Earth, but I realized Earth isn't.
It's not an exoplanet, at least from our perspective. Exactly. You know, if we were doing this show on Vulcan, Earth would be an exoplanet to pick.
This is very true. But I would definitely, if I was to pick one Star Trek planet to go to, it would be Earth of the future.
Earth in the future, yeah.
Yeah, no, the paradise that we see where we don't have what's going on in Earth just now. Yeah. Wars and plagues and all sorts of human suffering that goes on, and pollution and climate change. So definitely Earth of the future is the place to be. Do we have any other honourable mentions? I know we've mentioned a few outside our top three. On you go, Justin.
So as I was thinking about this topic, there were a few others that came up. One was Kronos, the Klingon homeworld, which we first see in Sins of the Father. Mm-hmm. Now, I mean, if you're going there, you might not, depending on the time period or what your mission is, you may not get the warmest of welcomes. But but I think it's pretty interesting because it is one of the things where I think it's identified. I don't know if this is on screen or in a Star Trek star chart or something, as orbiting a real star, Omega Leonis, in the constellation Leo, about 112 light years away. And actually we get a lot of, we first see Kronos in TNG, right? And you get to kind of see it, but we actually get the most information from Discovery, because I was looking at the Memory Alpha article, and almost all the information for the stuff on Kronos itself is actually from Discovery, where you see there's lots of caves and subterranean volcanoes and things like that, and that they're kind of chaotic weather systems and thunderstorms and all of that. I think, what we see in TNG is the first city, the capital on Kronos. I think even in Discovery, it's just kind of, it's a different part of the planet. But we've only seen little bits. I actually want to see more what things are like in different parts of Kronos, or if it looks different or whatever. But it's a planet that I've always been kind of fascinated by, and ever since we first saw it in TNG. So that's one. Another one is, and there's not much information on it, but it's more for what happens there, Eladrel 4 from Darmok. I know that that one's pretty obvious, they filmed it, outside of LA, but I think there is something that's interesting about this planet kind of being used for kind of this transformative experience that Picard has for understanding Captain Dathan and the Tamarian culture and all of that. So that came up as an honorable mention. Another one that came up is Mintaka 3 from Who Watches the Watchers with the proto-Vulcanoids. It does seem like it's a pretty, I mean, it is probably not as much greenery, maybe a little hotter or whatever, but I think the way that they did it looks kind of interesting, but it's more for the inhabitants, because these proto-Vulcanoids I think are super super interesting, and so I don't know if we have much more information about it, except that it's something like 1,500 to 3,200 light years from Earth, so it's fairly far away. And they did film things at the Vasquez Rocks for that. So those were my honorable mentions that I had, just ones that I thought, I really like seeing those and look forward to seeing those planets.
Nice. Mike, did you have any honorable mentions?
Yeah. So we already talked about Risa being in a binary star system. Another honorable mention for me was Wolf 359, the site of that giant clash with the Borg in the epic two-parter Best of Both Worlds. The reason why is because we now suspect that Wolf 359 actually has planets orbiting that star.
Because the reference we get is to the star, not to any particular planets, right?
Right. So Wolf 359 is a star. It's a real star, very close to Earth. Just last year, actually, astronomers found planetary candidates around Wolf 359. We don't know much about those planets yet, but that was an honorable mention for that. Then there's a planet or a planetary system called the Detrion system, where two gas giants are colliding to form a newborn star, which I thought was just a fantastic kind of occurrence.
Which one is that from?
I can't remember what the episode name is. Let me look it up. Detrion system is from TNG Ship in a Bottle. Yeah. So the episode is called Ship in a Bottle. It's the one where Moriarty sort of takes over.
No, and I think I was remembering. Yeah, so there's kind of one gas giant that's siphoning stuff off from another, and they're just trying to beam over samples. Is that part of what happens?
Yeah. You get this brilliant depiction of these two planets very close to each other, and one is siphoning mass off of the other one, and it's so amazing because this is not something that you just see in most sci-fi, this kind of cataclysmic event, but certainly planets do run into each other every once in a while. We think that our moon was formed by a giant impact where a Mars-sized body hit the Earth and stripped away a bunch of material, and that material coalesced and formed into our moon. So two giant planets hitting each other is not out of the question either. There is a little subtlety, though, that if you had two Jupiter-sized planets hitting each other, they probably wouldn't form a newborn star, but a newborn brown dwarf. So there is sort of this class of astronomical object that is bigger than a gas giant planet, but smaller than the smallest star, and they're called brown dwarfs. So two Jupiter-sized planets hitting each other would probably form a brown dwarf and not a star. They're not massive enough quite yet.
I suppose they're approaching the limits of what the mass requirement is to ignite stellar fusion. So if the gas giant was big enough, then if there was hydrogen, then it could ignite itself.
Right. So basically, a gas giant is sort of like a failed star in that it's a ball of hydrogen and helium that is not quite massive enough to ignite nuclear fusion, as you said. But there is that class of thing in between the two. So a brown dwarf is actually something that can do a little bit of fusion, a very specific kind of fusion where it can burn deuterium, but it can't actually burn hydrogen. So that's basically the distinction. And you essentially, I think, in order to create a real star, you would need to collide two brown dwarfs, or a brown dwarf with a gas giant. Two gas giants alone, I don't think could ever be massive enough to make a star. They would make something in this intermediate zone, brown dwarf. And in that depiction, just another note there. So if you go to the episode and you look at this brown dwarf, these two gas giants colliding, one of them is a lot larger than the other. It's like twice as large. And that's also possibly a slight mistake, because it turns out that planets don't really get much larger in size than Jupiter. Although you can have a planet that's more massive than Jupiter, if you put more mass into Jupiter, it doesn't actually get larger because its self-gravity becomes so large that it sort of contracts that material. And so it's sort of like this bell curve sort of thing where as you add mass to a planet, it'll get larger up until a certain point, and then you add more mass and it actually gets smaller because its gravity overwhelms the amount of stuff.
It just has a subspace anti-gravity field.
That's exactly it. Yes, there's the subspace anti-gravity field that's puffing up this planet, and that's why it looks so large. Absolutely.
I know I'm joking about it, but you can say subspace stuff and it helps.
Subspace, nadions, tetrons. We have it all in the Star Trek universe. Yeah. Okay, and then one last honorary mention for me is whatever planet the benzites come from.
Benzites. I think it's I don't know if it's the planet or the system is Benzar, I think.
Yeah. And that's just interesting to me because we know that they need these devices to help them breathe in our atmosphere. So it's always been a question that I've had. What are they breathing? And what kind of planet did they evolve on that requires them to breathe this other substance?
I've been fascinated by that as well. I looked it up. The planet is called Benzar in the Benzite system. But there is a Deep Space Nine episode where you see a Benzite who does not have that. So maybe they've made some kind of accommodation by then. But otherwise, I've always been fascinated by that since I think the first season episode, Coming of Age, where you see it and it's kind of this thing that's like plastered onto the uniform and kind of comes out and they can kind of breathe from it. But that would be really interesting. Maybe we'll see Benzar someday.
So I think one honourable mention for me would be any planet where the gravity is slightly higher than Earth. like Vulcan, because I would like to go there and be slightly heavier than I am. So
might
that
be a
my
good
muscles,
exercise routine.
Exactly. So that I just basically my muscles have to get used to carrying around my extra weight. And so I get like totally ripped and giant
awesome.
looking. So when I come back to Earth and I look like Kevin Sorbo.
That actually brings up maybe a bit of a pet peeve I have about Star Trek sometimes. Like when people like walk on these planets, like it seems like it's always the same gravity. I mean, that's probably practical because maybe it's hard to just like pretend that the gravity is heavier or to, kind of bounce around a little bit. But like,
your head to fall through your shoulders because the gravity's massive.
No.
Yeah.
But like, it may be hard to do, but I would be interested in more depictions of what it would be like in heavier gravity or even like slightly lighter gravity. I mean, you see sometimes like, weightlessness in different parts of Star Trek, but you don't see as much like heavy gravity or just like you're not quite weightless, but it's like, you're bouncing around a little bit on the planet. So we don't see that as much because you would think it would be fairly variable. You're not going to be able to, go to these places. It's just like one Earth gravity. And even when they're on Vulcan, like you can see like in a Muck Time in the original series, like it's harder to breathe, but you don't really see that it's more difficult for them to actually like do stuff and move. Right.
Yeah.
So
exactly.
Anyway.
Yeah.
Small thing.
Yeah, I chalk that up to the same thing as why there are so many humanoid aliens. It's hard to find a non-humanoid actor. It's hard to find a location to bring actors to that doesn't have one Earth gravity. But there was that character from Deep Space Nine, right? Melora.
Yes.
Melora Paslar. That's right.
Yeah, who
that's true.
Her species evolved on a planet with less gravity, so she needs this exoskeleton to wear to be able to stand up on standard.
And they have different gravity in her quarters. Yeah, I really like that as well. That's probably one of the few places where you actually see that, and you can see based on like what's happening in the struggle, and you get to find out more about her species. There's like a 2-book novel series called Gem World that I really love and highly recommend. That's about going to the planet that she's on, where there are like these different humanoid species that interact in this kind of low gravity environment. And this was, I think, before Enterprise had the Xindi with like all the different species on one planet. But yeah, that's a really great example, Mike, where we actually do see the effect of it.
Yeah. I suppose it's kind of like the same thing that happens to astronauts that have been on the International Space Station for a long time, where their muscles have atrophied and their skeletons are a lot weaker. Because apparently you start to pee out your skeleton or all the calcium in your skeleton as soon as you get to space. That's a graphic
way to put it, but yeah.
Well, no, you do. Yeah, your brain realizes you're in zero gravity, so thinks, I don't need a skeleton anymore because I don't need a support mechanism for my internal organs. So you basically start to break down all the calcium in your bones, and that's why astronauts can get problems with kidney stones a lot of the time because all the calcium's just been leached out. It's a lovely way to end our conversation of exoplanets in TNG. Mike, thanks for joining us today for this episode of Earl Grey.
It's my pleasure.
Been really good fun. Yeah.
Yeah, thanks for inviting me on.
I learned so much.
Yeah, I've learned so much as well. Can you tell people where they can find you online?
Sure. Yeah, you can follow me on Twitter at MikeWai. That's MIQUAI. And please, if you liked this discussion of the intersection of science and Star Trek, I host a podcast called Strange New Worlds, and you can get that wherever you get your podcasts.
Yeah, and highly recommended. I love the podcast and what you talk about on the show.
And I still feel like a bit of a podcasting newbie because I've hardly listened to any podcasts. So I will search out Strange New Worlds and give it a listen. Yes. So, Justin, you have a preview of what we'll be talking about next week.
Yeah, very excited about this. So we have been doing these Badass Moments episodes, and this came up from the news before Picard premiered that Whoopi Goldberg would be reprising her role as Guinan in Season 2 of Picard. So we are going to look at Badass Guinan moments.
That's exciting.
I think that's going to be a lot of fun.
Yeah, quite a lot of things to choose from Guinan.
I know she was in, I think, 28 episodes or something like that.
Yeah, and being such an enigmatic character. It's going to make for an interesting discussion. So I look forward to that. And Amy will be back, so that'll be fun, the three of us together again. Well, it's been so much fun talking about our favourite exoplanets in TNG today, but that isn't the only thing we've been talking about here on the network. Here is what you might have missed elsewhere on Trek FM.
Previously on Trek.fm, Primitive Culture, a look at history and culture through Star Trek.
I think the difference is that Flashback is intentionally trying to carve Voyager a little place within the fabric of the undiscovered country, say, and it's trying to place Tuvok. Well, it's trying almost to retcon, isn't it? Because Tim Russ was in that film as one of the Excelsior crew, so it's trying to do a retcon and say,
no, he was in Generations. He wasn't even in that film. That's the
wasn't he?
Thing. He was like, and I suppose it's a Brannon Braga episode as well. Brannon Braga wrote Generations. Brannon Braga, I suppose, must have realised maybe unconsciously realised that Tim Russ was in Generations as a different character.
He wasn't he?
It's almost like a weird sort of.
I've got that wrong. You're right.
I don't know whether on some. No, but I wonder whether unconsciously, on some level, that's the connection you're supposed to be sort of slipping into. And of course, he was serving on an Excelsior class ship.
Earl Grey.
I want to see that spaceship that's got giant space-time knitting needles, and they just like do that, like as they warp through space, fixing it behind themselves. That'd be awesome.
Literary Treks.
The one that I left out that in hindsight I regret it is the one where he's is it Wink of an Eye, where he's fighting the guy in the quarters and he actually throws a pillow at the other guy and it hits him in the face and stops him dead in his tracks for 2 seconds, long enough for Kirk to get the upper hand on him. And I'm like, I don't even know how to describe this. I don't even know what to give. I couldn't come up with a name for it. That was probably the biggest thing, is I couldn't come up with a catchy name for it. Pillow talk or something, maybe in hindsight I would have called that. But,
stopped him dead in his tracks because he's like, did you just throw a pillow?
Did you just throw a pillow? Yeah.
The Line, a Star Trek Picard podcast.
I think I've exhausted the planet.
Well, then let me end on a funny note. The first thing I thought when I saw that senator beheaded was, well, I guess we don't need to worry about Quentin Tarantino doing a Star Trek movie anymore.
Oh, yeah, I was actually quite surprised by that. But
and his blood was very bright green.
It was very bright green.
But,
yeah.
Bravo. Bring Quentin Tarantino back.
Yes.
And that's what else is happening on Trek.fm.
Check out all these shows and join the conversation about your favorite corner of the Star Trek universe and beyond. You'll find us wherever you get your podcasts. If you're an Apple user, be sure to hit the subscribe button in Apple Podcasts on iPhone, iPad, or Apple TV, or the desktop Apple Podcasts app to get the latest episodes as soon as they're published. And please leave us a star rating and written review. That helps others to find the show.
If you're not an Apple user, we've got you covered as well. You can find our shows on Google Podcasts, Stitcher, TuneIn, Spreaker, SoundCloud, YouTube, and most third-party apps, and you can stream and download the MP3 file from our website or grab the RSS link.
So, Joe, bonus question?
Please.
Yeah. So we've talked about exoplanets in TNG, but
yes.
let's widen it. What is your favorite exoplanet in all of Star Trek?
Do you know what? See the way they depicted Nepenthe?
In the most recent Picard episode.
Yes, I know we're not allowed to talk about that. But I thought, like, without exception, current Star Trek, Discovery, Picard, the visual aspect of the way they're depicting planets, the way you can go from being in orbit and then like, fly down through the atmosphere kind of seamlessly, as if they filled in all the wee blanks that we never see before. So there was the planet of the Seven Domes a few weeks ago on, was it the planet of the Seven Domes? Yeah, just really well-formed and well-thought-out planets. There was the, what's the name of the planet we met, the Coamila, I'm saying their names. Vashti, yeah. Just visually, it just looks like beautiful places to visit.
Interesting.
Like the imagination of people that are writing these things has just come alive, and with the visual effects they can do so much more than they previously did. But definitely Nepenthe, go there.
Okay.
And to have a house with shields on it, that would be super.
I know. That's awesome. So, like, actually, when I think about this, one that's an episode that I think doesn't get talked about that much, but that I really love just for its depiction of a planet, is the Voyager episode 30 Days, which has, like, the water planet. Like, it's kind of like this ball of water that kind of keeps itself together, and, you know, you see the shuttle kind of go into the... Yeah, like a space ocean. So that one has fascinated me. It's possibly pretty unrealistic this would actually happen, but like that one has fascinated me for a long time. And I think it's an interesting episode as well, where Tom Paris does this thing that kind of lands in the brig for 30 days, but
gets him demoted.
That would be my pick.
That is a cool pick. I like that. I always got the impression that water planet was artificially created somehow.
I think
with
it
the
was,
internal reactors that kept it liquid and kept it gravitationally bound had started to fail. And for it
I
to
think
lose
that's
water.
what happens. Yeah.
The other Voyager one is good. Is the one where time's going faster on the planet. Remember?
Yeah, blink of an eye.
Blink of an eye, and Voyager's
that's
caught
a great one too.
In orbit. Yeah, just to see how fast a civilization evolves.
I know, and Voyager influences like, I guess at some point it's hundreds or thousands of years of history. Yeah, that one's
exactly.
Very cool
as
well.
That's very cool.
Oh, good choice.
Nice.
Okay, so we'd love to hear your thoughts on today's show, and there are many ways for you to do that. The best place to join in the larger conversation is the Babel Conference, our listeners group on Facebook. Just type Babel, B-A-B-E-L, into the search field on Facebook, and it should come right up.
If you'd like to send us an email, you can use the form on our website at trek.fm/contact. Choose to send to a show and select Earl Grey. That will come right to us, and we might read your email on the show. You can also find the network on Twitter and Instagram at TrekFM and on Facebook at facebook.com/TrekFM. So Justin, where can people contact you when you're not visiting your Betazoid relatives on Betazed?
Oh, that would be nice. Well, when I'm not doing that, you can find me elsewhere on the network co-hosting The Line. That's our dedicated Star Trek Picard podcast. Do that now each week as we go through the Picard episodes as they air with my friends Chrissy DeClerc-Zalagi and Brandon Shea Matala. You can also find me on Twitter. I'm at TrekFan4747, where I tweet about nothing but Star Trek. And you can find me hanging around the Babel Conference on Facebook. So, Joe, where can people contact you when you're not deciding what would be the best variety of swimsuits to take to Risa?
That's an interesting question. I'd have to, before I chose any swimsuit, I'd have to live for a couple of years on one of these heavy gravity worlds, so my body looked right for some.
Oh, you're fine, Joe. You're fine.
Some skimpy speedos. I think I would do that. But when I'm not doing that, you can get me on the Twitter at JoeyJoe77UK. You can email me, joepodcasts@gmail.com, and you can get me on the Babel Conference.
So if you'd like to help us keep all our shows coming to you each week, you can become a patron in the network on Patreon. Visit patreon.com/TrekFM. That's patreon.com/TrekFM to get all the details. Perks include early access to episodes, exclusive content, producer credits, and more, available through our special patrons website, the Patron Zone. It requires a great deal of money to produce, host, and distribute these shows each month. We really appreciate any support you can give us and hope you'll join the team. Again, you'll find all the details at patreon.com/TrekFM.
We'd like to take this opportunity to recognise our current associate producers, Norman Lau, Michael Hueter, Thomas Appel, Chris Tribuzio, Jim McMahon, Justin Oser, and me, Joe Keegan. Thank you for supporting Trek FM, and especially Earl Grey. So join us next time for another cup of Earl Grey.
Things are only impossible until they're not.
Hundreds of billions of stars, with trillions of planets. The Milky Way is going to be a hugely exciting place to be.
Woo, Risa!
Yay!